This is the video for written homework number 5 for heat and mass. For this first problem, we're looking for time for the anneal time for these two metals, and then we're also looking for the rate of heat transfer, or just the rate of heat transfer, correct? Yeah, because that's what Q is. So what we're able to do is, because it's spherical coordinates, we're able to use this, we're just able to get this R value as a radius from the diameter. But then in order to determine if we have to use lumped or 1D, we have to use this BO number. So we use H LC over K, and that gives us 0.00185, which is less than 0.1, so we get to use lumped analysis. So we solve for B, and B gives us this number, and we use this to plug into this temperature difference equals e to the negative BT. So then in this instance, we're able to solve for T by rearranging, and then we get T as 2.79 minutes. And then further down, in order to find Q, we just use the regular classic MC delta T. But in order to find M, we just have to use rho V. And then we plug this M back in, and we're able to get for 542.5 watts is our heat transfer rate. The next problem dealt with semi-infinite solids, and we were able to assume that based on how the problem statement read. So based on this statement, we have to use this equation equals this error function minus exponential times another error function. But in each, and we have to do this for 0, 0.1, 0.2, and 0.5 meters of depth of the soil. But because this exponential always goes to infinity, this whole term in turn goes to 0. So for each one of these problems, we just look at the error function and then go to table 4.4, and then we're able to pump out values in order to solve for Tx, or for whatever depth we're at time, and that gives us, for each problem it works the same way. Just go to table 4.4 and get the value you're looking for and solve for the temperature. For this third problem, we were looking at another sort of system of an ice block melting. So we looked at we had to get BI numbers for the whole ice block, and then we had to get BI numbers near the base. So we were able to get these. Once we got these values, you go to table 4.2, and you get your lambda 1 and your A1, and then you do the same thing to get lambda 1 base and A1 base, and you plug that into this equation in order to solve for time for how long it would melt. And then using solver, because I didn't feel like really rearranging this value and solving this out, I just used solver in Excel. I was able to show that this was around 70,000 seconds and 19.4 hours using A1 and lambda 1 values I didn't interpolate for, because Gardner said if they're close enough to the value, just find the number that's nearest it. And then finally, the last problem was another semi-infinite solid, but this was looking for concentration. So we just did the same idea, concentration, as like with the temperature one, but because we had 40%, we were able to solve for the original concentration, which is 0.6. Then you take an inverse of the error function, and you're able to pump out whatever value you're looking for at a specific time. So this can be solved in Excel differently, but in this turn, it worked out to do the inverse error function. And then in points of confusion, there were none as far as this week proceeded.